Okay, in this presentation, we talk about the arterial blood gas. At the end of this presentation, you will understand the reference of arterial blood gas analysis in acute clinical setting. You'll understand the normal arterial blood gas parameters, understand the acid-base balance, and be able to recognize metabolic and respiratory differences. And finally, understand when to alert or to notify medical staff. So initially, let's talk about our introduction about the arterial blood gas. It's an invasive procedure, and usually it has to be drawn from the artery. This is the most, or the first choice is the radial artery, and there is an alternative site to where to get the arterial blood gas, such as brachial, femoral, or dorsal as well. Also, blood gas provide us with information, the oxygenation and acid-base abnormalities or acid-base status. When and why to check ABGs? It's to provide valuable clinical information in actually ill patient with both respiratory and metabolic compromised. And also, if there is any sudden deterioration of the patient's condition, such as changing in the respiratory rate, cyanosis, confusion, or there is an altered mental status, so ABG could be helpful in such cases. So there are parameters where we have to check in the ABG. We have pH, PO2, PCO2, bicarbonate or HCO3, PE, base axis, and finally SaO2 or oxygen saturation. So pH has an indirect proportion to the hydrogen ion concentration. And the normal value for the pH, the ABG, is 7.35 to 7.45. So this is our normal value for the pH. But you have to pay attention for that any small changes, either below 7.35 or above 7.45 could be a serious condition. The PO2 and PCO2. The PO2 representing the oxygenation, the partial pressure of oxygen, and CO2 is the partial pressure of carbon dioxide. It has the result usually comes with different units such as the kilopascals or a millimeter of mercury. So if you got the results or your machine is providing a unit of kilopascal and you want to convert it to millimeter of mercury, so you have to multiply by 7.5, and versus if you got the results in millimeter of mercury, you want to convert it to kilopascal, you have to divide by 7.5. And HCO3 or bicarbonate referred to as the medical component, the metabolic component in the blood. The base axis refers to the amount of the base which needs to be added or taken away from the blood in order to get the pH to the normal value. If the normal value for the 5 parameters we have to check, so the pH is 7.40 plus minus 5, the PCO2 is 40 plus minus 5, the PO2 is 80 to 100, the bicarbonate is 24 plus minus 2, and saturation usually comes of 95 or 97. So we have in this slide, let's discuss about some technical errors, such as in heparin. You know that if you draw blood gas, it has to be, the syringe has to be heparinized. If it's not already pre-heparinized from the manufacturer, you have to add less than 0.1 ml. Otherwise, if you increase the heparin amount in the syringe, this will affect your results. And also delay in measurement. So rate of changes in pH, CO2, PO2 could be reduced if you got delayed, and also air bubbles in the blood sample before feeding the machine could affect increasing the PO2 and reducing the amount of CO2 or PCO2, and this is the results might affect your management. Also, pay attention for the delay in feeding the syringe to the APG machine. Fact about acid-base balance. So we have a CO2 is the respiratory component, and it moves opposite the direction of pH. If the pH is either below or above the normal value, so you usually look to the CO2. If the CO2 is the cause, so you will sit into the opposite direction. And if the cause is the bicarbonate or HCO3, so it moves to the same direction of pH. So here we have some examples. So here we'll talk about respiratory. Now the cause, now the pH is 7.25, which is below the normal value, since the normal value is 7.35 to 7.45. Now CO2, the normal value is 40. Now it's high. It's against or in the opposite direction. So the cause why the pH low is CO2, where the bicarb is normal. Let's not concentrate on the bicarb in this example. Let's focus more on pH and CO2. So pH is low, CO2 is high. So the cause why the pH in the low value, because of the CO2. So since it's low, it's acidosis, so we call it respiratory acidosis. Respiratory acidosis. Here another example for respiratory alkalosis. You will see the pH above the normal value. Again, CO2 in the opposite direction. Bicarb is normal. So again, the pH is 7.5. It's above the normal value. CO2 is low. So the cause why the pH is high is due to the CO2. So we call it respiratory alkalosis. Metabolic acidosis. So pH is low, below the normal value. CO2 is normal. The bicarb is low. So they move both in the same direction. So we call it metabolic acidosis. Metabolic alkalosis. See the pH 7.5, which is high. CO2 is normal. But look to the HCO3 or bicarb. So in the same direction, it's the bicarb is above the normal value, and pH is above the normal value, so we call it metabolic alkalosis. There are some conditions. We'll discuss it, inshallah, in the next slides. So in the compensation, or how can we get the pH to the normal value, we have different or three categories. We have full compensation, or partially compensation, or uncompensation. So full compensation, partial compensation, and uncompensation. So if the cause is the metabolic, so the compensation comes from the CO2 or from the respiratory. If the cause is the respiratory, why the pH is changing, either goes above the normal or less than lower than normal. So if the cause is the respiratory, so metabolic will take over the compensation. But remember that the metabolic compensation is always slow, and respiratory compensation is fast. So here we'll have some examples, three different examples about uncompensated, partially compensated, and fully compensated. When do you have to say is uncompensated? See, look to the pH. pH is still low. The bicarb is low. So this is metabolic acidosis, but the PCO2 in the normal value. So it's 40. So there is no compensation, or CO2 do not try to compensate in order to get the pH to the normal value. Let's discuss the partially compensated, which means that the pH still did not reach the normal value, and the cause is the biocarb and the CO2 start to goes down in order to get the pH up. Here is fully compensated. Now pH in the normal value, the biocarb was the cause why the patient or the pH in the acid side, and the CO2 goes down in order to get the pH to the normal value. Here we have fully compensated since the pH goes to the normal value. Here we have a partially compensated. CO2 is trying to fix or to get the pH to the normal value, so we call it partially because it's partially compensated, start to move. But here no compensation at all because of BCO2 in the normal value. This is in both directions. So if the CO2 is the cause why the pH above or lower the normal value, so pH biocarb will take over the compensation. So here we have some causes for why the patient might go to respiratory acidosis, such as drug hypoventilation due to drug overdose, for instance, narcosis, airway obstruction, respiratory arrest. So the CO2 will get up and the pH goes down. Respiratory alkalosis for anxiety, hyperventilating, so the patient is washing out more CO2, so pH, since they are moving in the opposite direction, so pH will go above the normal value. Fever also as well. CNS infection could cause respiratory alkalosis. Causes for metabolic acidosis, we have ketoacidosis. It's usually you will see it with the diabetic patient. If there is an renal failure, also patient might have metabolic acidosis. If we have a lactic acid decrease, such as decreased tissue perfusion, severe hypoxemia, cardiac arrest, and excessive diarrhea, all could cause metabolic acidosis. Causes for metabolic alkalosis, we have vomiting, as an example, hypokalemia, gastric suctioning, and excessive alkaline take. So finally, this is an example. So let's discuss here the pH. The pH is low. Now, pH is low since the normal value is 7.35 to 7.45. So pH is 7.26, which is low. So this is acid. Now, so far, if I will review the pH, okay, now I'm dealing with the acid case. Patient is acidotic. Now, I don't know what's the cause. Is it respiratory or metabolic? So let's review now a respiratory representative here, which is a CO2, partial pressure of carbon dioxide. So it's 32. So this is low. This is low. So what do you think about it? If both are low, so remember, if the respiratory is the cause, it goes in the opposite direction. So this is not the cause. So let's come here. The biocarb is low since the normal value is 24 plus minus 2. So 18. It goes with the same direction with the pH. So it's a metabolic acidosis. Now let's review if there is any compensation. So pH is the normal value is 35 to 45. So there is movement, slight movement goes down in order to get the pH up. So we call it partially compensated metabolic acidosis. Thank you, and I hope that you got some benefits from this presentation. It's my pleasure to be with you. Thank you.